Okay, let's talk about one of the most fundamental things in all of software engineering. How do we give our systems a memory? And look, I'm not talking about RAM. We all know RAM is forgetful. The second the power goes out, poof, it's gone. I'm talking about a real long-term memory, the kind that can survive a restart, a crash, you name it. How do we build software that actually remembers? Well, let's get into it.
No, seriously, just think about that for a second. What if every single time you closed an application, it completely forgot everything? Your saved game, that report you were working on, your profile, all of it, just vanished. That's a rule with software amnesia, and it's a world that we, as engineers, have to build against. And the way we do that is with a concept called persistence.
So here's our plan for today. First, we're going to face the threat of system amnesia head on, so we really get what's at stake. Then, we'll build our first bridge to a solution with JDBC, where we have complete manual control. After that, we'll see how the Spring framework wraps all that up to make us way more productive. And finally, we'll look back at the whole journey, from that raw control to modern convenience. Ready? Let's go. All right, part 1, the threat of system amnesia. Before we even think about writing code, we need to understand why data persistence isn't just a nice-to-have. It is absolutely 100% non-negotiable for any serious application. So what exactly is persistence? Well, at its core, it's just the process of taking data out of that speedy but temporary RAM and saving it to something permanent, like a hard drive or an SSD. It's the only way to make sure your data outlives the program that made it. You can think of it like this. Persistence is the system's long-term memory. It's as simple as that. Now, this whole system amnesia thing, it's not some abstract threat. It happens constantly for 3 main reasons. First, you've got your basic process shutdowns, routine restarts or just closing an app. Second, memory exhaustion. If your computer runs out of RAM, the operating system is going to start shutting programs down to survive. And third, the big one, power outages. The lights go out, and every bit of data in volatile memory is gone, instantly. Without a persistence plan, any of these will wipe you out. So how do we store data safely? Well, for a long, long time, the answer has been relational databases. Think MySQL or Postgres. And a really good way to picture how they work is this parking garage grid idea. Imagine every piece of your data, say a user profile, is a car. The database is a huge parking garage. And that car isn't just parked anywhere. It's in a specific numbered stall, that's a row, which is in a very specific section, that's a table. This super rigid structure means the system can find any car, any piece of data, perfectly, every single time. Okay, so we've got our data, our car, and we've got our parking garage. The next question is, how do we actually get the car from our app into that parking spot? This brings us to section 2, the JDBC Bridge. This is the classic foundational manual way we connect our Java code to a database. Now, talking to a database with JDBC isn't just one action. It's more like a ritual, a very strict 6-step life cycle you have to follow perfectly every time. And we're going to walk through this very, very deliberately. Why? Because understanding these 6 steps is the foundation for everything else. Even the most modern tools are just doing this ritual for you under the hood. So let's break it down. The first couple of steps are all prep work. Step 1 is kind of obvious. You got to have a database to talk to, and your application needs to be able to reach it. Step 2 is about getting the right tools. You import the java.sql library. This is like getting a toolkit. It doesn't build the house for you, but it gives you all the essential pieces, the classes like connection and statement that you're going to need. Okay, now for the handshake. Step 3 is loading the database driver. This piece is critical. It's a translator. Your Java code speaks a generic kind of database language, but the driver translates that into the specific dialect that MySQL or Postgres or whatever you're using actually understands. Then in step 4, you actually use that driver to connect. You provide the address, the username, the password. This opens up a real live session with the database. The line of communication is now officially open. And finally, we get to the main event and the cleanup. Step 5 is where you do the work. You issue your SQL commands to get data, save data, update data. But Step 6 is maybe the most important and the most dangerous if you forget it. You have to explicitly close the connection. Think of it like hanging up a phone. If you don't, that line stays open, using up resources. If enough of those lines are left open, the database runs out of connections and just locks up. It's a classic resource leak, and it can bring your whole system down. That's why it's a ritual. You have to complete every step So yeah, that's the process. It's powerful, and it absolutely works. But as this quote says, JDBC offers ultimate control, but it imposes a heavy maintenance burden. And that really is the perfect way to describe the trade-off. You can control every little thing, but that control costs you a lot. And what is that cost? We call it the boilerplate burden. See, for every single database query, you have to write this big, clunky try-catch finally block. You open the connection in the try, you catch any errors in the catch, and you have to meticulously close everything in the finally block to avoid those leaks. You end up with dozens of lines of repetitive code wrapped around one single line of actual SQL. It's tedious, it's slow, and honestly, it's a breeding ground for bugs. But before we move on from manual JDBC, I have to talk about one feature that is an absolute non-negotiable part of security. It's called a prepared statement, and its magic is that little question mark placeholder. Think of it as a security circuit breaker. It basically locks down the structure of your SQL command before you plug in any user data. This means whatever a user types in is treated as simple text, not as code to be executed. And that one thing is what stops one of the most dangerous attacks out there, SQL injection. So remember this, if you're writing JDBC by hand, you must use prepared statements. Okay, so we've seen the raw power and, let's be honest, the pain of manual JDBC. That brings us to section 3, the Spring wrapper. This is the evolution. This is the solution designed specifically to kill that boilerplate burden using a tool called JdbcTemplate. And this table just lays it all out perfectly. Connection management? With manual JDBC, you're writing those messy try-catch/finally blocks yourself. With Spring, it's all automated. Error handling? JDBC gives you these weird database-specific exceptions that are hard to understand. Spring translates them into clean, readable Java exceptions. And resource cleanup, that crucial close call, manual and JDBC totally automated in Spring. And look at the last row. That's the real payoff. Your focus shifts from writing plumbing and boilerplate to what you actually care about, your business logic.
The thing that makes all this happen is the JDBcTemplate. It's a productivity wrapper. It's a core tool in Spring that basically handles the entire JDBC ritual for you. It automates opening and closing all the resources, and it acts as that awesome error translator, turning cryptic database gibberish into a clear hierarchy of exceptions that you can actually work with. Using Spring JDBC also naturally leads you to this fantastic design pattern called the repository pattern. And my favorite way to think of this is as an object-oriented concierge. Instead of having SQL code scattered all through your app, you put it all in one dedicated place, the repository. Now, the rest of your application doesn't need to know anything about databases. It just goes to the concierge and says, hey, can you find user 101 for me? And the repository handles all the messy details behind the scenes. It's clean, it's organized, and it's just a much better way to build software.
All right, let's wrap this up in our final section, from control to convenience. We've really come a long way, from the basic problem of a system with no memory, all the way to a clean, modern solution. Let's just quickly recap the big ideas.
First, persistence is memory. Simple as that. It's the only way to cure system amnesia. Second, JDBC is control. It's the foundation, it gives you total power, but it comes with that heavy boilerplate burden. Third, prepared statements are security. That little question mark is your circuit breaker. It is non-negotiable. And finally, Spring JDBC is productivity. Things like JDBcTemplate and the repository pattern free you up to focus on what really matters, your business logic, not the plumbing. So we've made a huge jump, right, from total manual control to this automated, productive world. We've cleaned up our code, we've made it safer, but we're still writing SQL. Which leads to one last, really interesting question. What if we could stop? What if we could stop writing SQL pretty much entirely? Now, that might sound a little like magic, but it is very, very real. It's the translation magic of something called Object Relational Mapping, or ORM, and the Jakarta Persistence API, JPA. And that is exactly what we are going to unpack in our next explainer. Thanks for watching, and I'll see you then.